Hey, it's T. I'm one of the geniuses at AskZylor. So let's just get started with the live session. So we're going to get started with some vectors questions. So we're going to go really simple and then we'll get a little more complicated as we move on. So our first question says, determine the vector and parametric equation of a line that passes through the points A and B. So the first thing we should be doing is finding the vector equation, so because we can derive the parametric equation from the vector equation. So my vector equation is going to be in this form. It's going to be a point plus a slope, and then t will be my parameter. So we should be trying to find what this direction vector is. So my direction vector can be usually found. It passes through the points A and B. So I'm going to find what the AB vector is. So that's going to be my XB minus my XA and my YB minus my YA. Right, so I have 0 minus 4 and then have 3 minus 2. So that's going to give me 4 and 1 as my direction vector. So I have a direction vector and then I have to find a point on this line. So I'm going to write my direction vector in this format, and t is my parameter still, and a point on this line. So for the point on this line, we can use A or B, it doesn't really matter. So I'm going to choose to use B, so I have 0 and 3. And this is my vector equation. I have a point, I have a direction vector, and I have my parameter. The next step is to find my parametric equation. So my parametric equation should be in terms of t. So I'm going to replace r with x, y. That's equal to the same as my vector equation. And then I'm going to write an individual equation for x and an equation for y. So my x, I'm going to add all my x terms. So I have 0 and 4 times t. So I have 0 plus 4t. In other words, I have x is equal to 4t. And then my y is going to be 3 plus 1 times t, which is going to give me t. So I found my vector equation, and from my vector equation I came up with my parametric equations. So it's another knowledge-based question. So what we need to do is we need to plug in the point negative 720 into each of these equations and then compare what the t value is. My parameter t is going to be the relation between my x and y values. So that means if my t values are different when I plug the points in, it's not going to be on the line. If my t values are the same when I plug my values in, that means that point is on the line. So what do I mean by that? I'm going to go ahead and plug in. So I have x is equal to negative 1 minus t, and my point is negative 7 and 20. So I'm going to plug the x value of that point into my parametric equation. So it's going to be negative 7 equals negative 1 minus t. So my t is going to equal to 8. I'm going to do the same thing for my y. My y is going to be 4 plus 2t. And then again, I'm plugging my 20 into this equation. So 20 equals 4 plus 2t. And that simplifies to 8 as well. So what that means is my parameters are the same. So that means Does this point lie on the line? Yes, it does. So we have the parametric equations of a line given to us, and this line crosses the x-axis at the point with coordinates A and the coordinates B. If O represents the origin, determine the area of the triangle AOB. So before I start, I'm just going to draw a small diagram to show what I'm trying to solve here. So my point A, my point B, and I have O, which is the origin. So this is going to be O. And A could be either positive or negative, and then B could be positive or negative as well. But the main point is, let's say my A is positive, this little a. That means this is going to be A, and this point is going to be my A, big A. Right? Because 0 tells me it's on the x-axis. And this 0 tells me it's on the y-axis. So let's say this is B, for example. Right? So it's always going to make a right angle triangle. We'll see why that's important in a second. So what I'm going to do is I'm going to plug in both these values into these equations. So I have A 0, I'm going to plug that into x equals negative 8 minus s. And then I'm going to do the same for my y parametric equation, 4 plus 2s. So my A value is, for my x value is going to be A. So I'm just going to make that clear. This is going to give me A equals negative 8 minus s. And then I'm going to plug in 0. It's going to be 4 plus 2s. So my s is going to be negative 2. And then if I plug s back into this equation, I have negative 6. So I found my A value, which means I found my A coordinate. So I have negative 6 and 0. So I'm going to take the same steps for my B coordinate. So I have 0 and B. And I have the same parametric equation. So I have negative 8 minus s, and y is equal to 4 plus 2s. Now it's not going to be the same s value because there are two different points. So I need to find what my new s value is in order to find what my b is. Right. So I'm going to plug in these values again. So I have 0 is equal to negative 8 minus s, which gives me s is equal to negative 8. So I'm going to plug this back into this s, my y parametric equation, to give me 4 plus 2 negative 8, which will give me negative 12. So now I have my b coordinate, 0, negative 12. So why is all this important? Because they're saying determine the area of the triangle AOB. So I can't find the area of the triangle unless I have the base and height. Right? In other words, what's my x value in my A coordinate? What's my y value in my B coordinate? So now I've found it. Right? So my area is going to be base times height times 1 over 2. So my base is going to be, what's my x value in my A coordinate? It's simply going to be negative 6. I'm just going to plug in 6 because I don't care if it's moving left or right. And then for my height, I'm just going to plug in 12. So my base is 6. I have 12 times 1 over 2. All that's going to give me is 36. So what's my area? My area is 36. Any questions about this? So what I've done so far is they've given me a parametric equation of a line, and they've said this line crosses the x-axis at a certain point and the y-axis at a certain point. And 0 represents the origin, so we'll determine the area of the triangle AOB. So my O is the origin, so I came up with a right angle triangle, so all I needed to do was find the base and the height. Because if I have the base and height, I can just plug it into my area equation to give me my area. So we're getting to more application type of questions, application thinking. So what is the angle between the lines? We're given a vector equation and two parametric equations. So this is one line, this is one line. So they're asking us to find the angle between the lines. So from the previous unit, you might remember that a dot product between two vectors, so if I have R and U, it's equal to the magnitudes of these vectors multiplied by our cos of the angle between the two vectors. So what I need from each of these equations is a direction vector. So my vector equation already gives me a direction vector, so I'm going to use it the way it is. I have 1 and 2. I'll say this is R1, and my R2 has the direction vectors associated with the parameters. So it's going to be 3 and 4. So now I have two vectors, and they ask me to find the angle between the lines. So what I'm going to do is plug these into my dot product of two vectors. So I have R1, R2 is equal to the magnitude of the two vectors times the cos of the angle between them. So I'm going to rearrange this equation to give me my angle. So I have theta is equal to cos inverse R1, R2 divided by the magnitudes of each of them. So once again, we're doing some vectors questions, so some common questions you might see on a test. So if you have any questions you would like us to work out, please send them in and we'll be happy to help you. So right now we're doing some vectors and parametric equations questions. So these are more thinking application type of questions. So we're hoping you are working along with these questions. So right now what I've done is I've done the cross product of the two vectors. So all I'm doing is just plugging the values in. So my cos inverse is going to be the dot product of the two vectors. So my two vectors were 1 and 2 and 3 and 4. Right, so I'm going to multiply the x's and the y's and add them together. So I'll have 1 times 3 plus 2 times 4 divided by the magnitudes for both of them, which are going to be square root 5 and square root 25. So when I plug all that into a calculator, my angle is going to be 10.3 degrees. If you have any questions, once again, please send them in. So this is how I found what the angle between the lines were. I didn't really care. So there's a question that says, do the points on the line matter? Like 40 and the negative 314. The points don't really matter, because what we care about are the angles between the lines, and that's going to be told by the vectors themselves. So all we care about are the vectors 1, 2, and 3 and 4. The points could be any point on the line itself. It doesn't affect us, it doesn't change the answer. The dot products involve the vectors, in other words, the slopes of the line. So the points on the line aren't really involved. So I found the dot product I know the dot product is equal to the magnitudes times the cos of the angle between the lines. And this is why I came up with the angle. We posted these questions on our story so that you guys can try them before we go through them. And once again, if you have any questions, send them in and we'll be happy to do them as well. So this question says determine the equivalent parametric and vector equations of the line. So we have the y equals 5x plus 3. So what we're going to do is we need to find, I'm going to find the vector equation and then find the parametric equation from the vector equation. So once again, my vector equation is in the form of, let's say R is my vector. I have a point, so x and y plus m times t, where t is any element of a real number. So it's t is my parameter. So my vector equation, this m can also represent the slope. Like my direction vector can tell me what the slope is. So they've given me the slope, so I'm going to use that. So my slope is usually in the form of rise over run. So my rise is given by my y values, my run is given by my x values. So this is going to tell me what my direction vector is. My slope is 5 over 2, so my y is going to be 5, my x is going to be 2. So my direction vector is going to be 2, 5. Now we also need a point on this line. An easy point that we can always get from this general equation is going to be the y-intercept, because if we plug in 0 for x, we have y is equal to 3, right? So I have a point 0 and 3. So I'm going to use that point, 0 and 3. That is my vector equation. So once again, we need to find my parametric equation. So I need to replace my r with x and y. So that's equal to 0 and 3 plus 2, 5, and t. So what I'm going to do is add up all my x values. So I have x equals 0 plus 2 times t. So I just have x is equal to 2t and y is equal to 3 plus 5t. So if anyone's tuning in right now, we're going through some vectors questions. So we're mostly focusing on parametric equations, how to convert between Cartesian equations, parametric equations, and vector equations. So we were given a Cartesian equation. Given a Cartesian equation, we had to find the parametric and vector equations. So I decided to find my vector equation first by finding what the slope is. My slope is 5 over 2, and that translates to my direction vector, which is 2 over 5, because I know my slope is rise over run. And my rise is given by my y values, and my run is given by my x values. So that gave me my direction vector 2, 5. Then I had to pick a point on the line, so I picked the y-intercept, because that's an easy point I can always use. So I found 0 and 3 to be a point on the line. So this is my vector equation. Then we had to find a parametric equation, so I replaced r with x and y, and I found x is equal to 2t, y is equal to 3 plus 5t. I just added each of those components up. So we had a question sent in that's very similar to what we've been doing so far. So it says determine the vector equation of the line passing through the point 1, 3, which has 2, negative 1 as its normal vector. So 2, negative 1 as its normal vector. So that's going to be key, and it's just given a point. So I'm going to say r is equal to a point plus my direction vector times t, which is my parameter, my parameter is any element of a real number. So my equation is passing through a 0.13, so I can substitute that directly in. But 2, 1 is its normal vector. So normal vector means it's going to be perpendicular to the line itself. So let's say I have this line. My normal vector is going to have a 90-degree angle with itself, with that line. And if my direction vector is 2, -1, that means I get the negative reciprocal of that to give me my direction vector for the line itself. So I'm going to have 1 and 2. So just to illustrate that, my slope is going to be -1/2, given by 2, -1. And then my negative reciprocal of -1, 2 is going to be 2/1, right? Which is shown by this. So what's my direction vector going to be? It's simply going to be 1, 2. I have a point, I have a direction vector, and that's all I have to do, because they're not asking me for my parametric equations, and they're only asking me for my vector equation. So we've gone through the usual questions you'll come across for parametric equations, converting them into vector equations and Cartesian equations. So this is the second live session for the day. We've done a first one which included a lot of calculus. So if you did miss the first live session and you wanted to do see how some usual calculus questions are answered, we'll have the recordings in our YouTube channel, and you can find that through the link in our bio.